This is just a square to round, but it's got a slight twist to it. It's offset. So as you can see, the circle is not in the center line of the square. It's offset in two planes actually, and I've actually put the circle on the corner. It looks complicated, but when it's broken down simply, it's really easy to understand. So let me break it down simply. To start with, I've drawn the basic information ready for us to go, which is the plan view, which is the view looking like this. I've drawn the end elevation, which is the view looking like that. Therefore, this is as round, this is as square, and we're looking at it from that kind of angle. I've also drawn in preparation as table of true lengths, which is as plan length against its vertical height. This height will always be a constant because it's the same height for everything. And these are all obviously true lengths in their own right because we can measure them accurately and represent it against the model. So as always, we'll divide the circle up and we'll divide this circle up and we'll divide this into 24. The reason for being this is I want to create more bends, more accuracy. It's quite a complicated shape, so I want to make sure I can get as much to the shape as I can, and more bends will help create a nice tighter fold all the way around. I'm going to create the spacings using my radius, as I always do. All equally spaced now using the radius. This gives me 12 points. I want to have 24 points, so I'm going to bisect this spacing, and that half will give us the spacings we need in between here to create 24 spacings. As they're both at the same diameter, I'm going to draw that and divide that up using the same spacings. All the spacings are in place now, and I've noticed how I've numbered them. I've numbered this bottom half 1 to 12. I've marked these A through to K. The reason why, all these points are different. So when we start plotting, I don't want to lose my reference. I've also marked the same markings at the top again, so I don't lose my reference, because there's a lot of things going on. We just need to make sure we get the right points for the right points. The trickiest bit in this is probably making sure we get the right points to the right points. So the way I always remember it is this is a quarter. Luckily, it's marked as a quarter. This is a quarter. This is a quarter. This is a quarter. This goes to this quarter. This goes to this quarter. This goes to this quarter. And this goes to this quarter. It's quite as simple as that, really. That's 90 degrees. That's 90 degrees. So it all makes common sense. Start joining these lines up now in the relevant places to help highlight which points we're going to start plotting. With all the points drawn in now, we start to look a bit more like the model. It's a good 2D representation of what we're making in 3D. Before I start marking, I've got an awareness that I want the red bit to be the outside. So if it was stainless steel, you might want the polish on the outside or some particular finish on the outside. So I'm aware that I want the red bit on the outside. So because of that, I've got to think about that when I'm developing it out. So I've got to think about it by looking on the inside to develop it out, as opposed to looking at it from the outside. So with that in mind, I want to start with CD. So I'm going to start my development on that baseline there. So with this in place, D and C, this helps make sure that we've got the right orientation for where we want it when it comes out. And also it gives us a point to start with to start plotting out our development. With starting with this, the first point I'm going to pick up is number 12. So I need to get a true length from D to 12 and a true length from C to 12. We know how to get a true length. We plot the plan length against the vertical height, and that will give us a true length. Why we do this is because if you look at the model, if we measure it off that, it's actually sloping away from us. We can see how it's not the right dimension. That dimension there is only looking on the top. It's not giving us a full true length. So by measuring the plan length and plotting against the vertical height, which is constant because that's the height we require, that will give us a true length, which in essence is just the hypotenuse of what we need. So with that information, I will now crack on and find point 12. So it's first point in place, number 12, D, C, 12. This is this triangle here. Now it's a simple case of working his way around on this quarter, from this point, working his way out. So the next point I'm going to pick is D11 and get its true length. With that true length in marked and ready to go, we need to find how far it comes away, and it's quite a simple process of using the spacings we've already got. That spacing is then marked from number 12, get to the arc, and that will give us number 11. Now it's a simple case of rinse and repeat. We can do the same with 10, 9, 8, 7 and 6, and that will bring around. All plotted in place this quarter. We can now see the shape come in. So what I'm going to do now is start plotting this quarter out from C through to A, through to F. As we can see from the development now, we have got this base, which is this base here. We've got all the points around to there and all the points around to there. We now need to get where this base lands in relation to that and where the other base lands in relation to that. We know there's going to be two sides on there, which are both going to be exactly the same size. So once I've plotted this one side, I can then plot it on this side, give it an arc, and plot it on this side and do the same. So both sides are marked on, both sides of the developments. We can work to either side now. I'm going to work from D to A. So this will be my A point. I need to find my A point. So we know where the 6 is. It's already there. I need to get a true length from A to 6. This side done. I'm going to go on to the other side now, as we've got the point already marked out. I need to get B to F as a true length and get that plotted on there to create the next point. So this point in place, and this point in place, we're now ready to finish off the development. I'm going to go on to A. So we're going to come around here. I'm going to make this the joint line. Unusually, this is no longer triangulation, this last quarter. This is more like a cone development, more like a radial line method. So we've got the true length already plotted out from A to 6. We've plotted it out. So that is just true length. All I need to do with this now is take this true length, strike an arc, mark as spacings all the way down to 0. That now brings us right round to his joint. This bit completed, this takes me right round to this joint line. We just need to get round now on this other side to where we're going to go. So I'm going to start by taking B to G, B to H, and so on, round to this next quarter here. That is pretty much most of the development complete. We've got this bit done. Just need to finish this bit off now. Again, we'll take the side length. We're going to arc that out, and we're going to get the true length of this joint line here, arc that and connect it, and that will finish off our development. That's pretty much it. I'll just fill these points in here, and this will show the shape a bit more. All marked out now. Let me transfer that onto some card, and let's try it out. So as we can see, it looked complicated, but once we broke it down into simple steps of triangulation and a little bit of cone development, a basic understanding helps us solve a really complicated problem. So that's another one down and on the shelf. What's next? Let me know.